Cool. So as mentioned, chapter 8 is going to be finished with a big in class, or you can take it home too. It's going to be a big project where I will help you as much as I can. You use essentially 4 different formulas to work through it. And it is going to involve planning for your retirement. And so for most of you, that's going to be in like 45, 46, 47 years, right? It's going to be a long time from now. But that's the beauty of it. Hopefully by the end of this chapter, you will see that the greatest weapon you have and your road to wealth, I guess, and your advantage on someone like me is time. Those 47 years are going to be invaluable. So take it to heart. Today, we're going to do 2 things. Number 1, I would like us to explore what interest is. There are 2 types of interest that we can look at. It's simply, no pun intended, simple versus compound interest. I'm going to use the word simple interest, the type simple interest, to introduce to you what interest actually is, but also give you a disclaimer that it's rarely used today. Compound interest is what we often use today, and that's lucky for us because compound interest is literally our exponent equation. If you remember, it's VF is equal to VI 1 plus R to the power of T. So instead of saying initial value and final value, we're talking about money. So we simply turn it into 2 different letters. And then you'll understand what those 2 letters are much later. Okay? Let's talk. Before we get into this lesson, anyone have any idea where interest comes from? It's a very deeply rooted cultural aspect, and it wasn't normal until banks essentially adopted it. Anyone know where? Yep. It is like tipping. That's a really good analogy. Do you know what culture? Yeah. Actually, again, I'm not a anthropological buff. I'm not an expert, but from my own studies, what I do know is that, interest was actually a way of saying thank you for having someone lend you money. And I believe that was actually from Jewish or Hebrew culture, right? So going back to, the Jewish religion or culture or belief or faith, whatever you want to call it, the word of God says, if someone did something for you, you pay them back in full and then some, right? And so I don't know what their religious book actually says. I forget, but I think it's like over 10%. Like you actually gift them back 20% as a thank you. It's huge. But like, how do you show how genuinely thankful you are if the gift is not extravagant, right? And so banks, I believe, saw this part of culture and they're like, hey, why don't we do that? And long story short, if you borrow something, you pay back with interest. If you let the bank borrow your money, they will give you your money back with interest. So let's explore what interest looks. We're going to look at, for lack of a better way to describe it, we're going to look at simple interest, interest that is simple. Before we begin, I'm going to give you the equations. The interest, I, is equal to P times R times T. What is P? That's your starting value. So in terms of exponential, like that, we call that VI, right? I is your interest. R is your interest rate per year. So it's the percent rate per year, annual. And T is time, usually in years. Why is it in years? Because the interest rate is usually in years. I need you to understand that the time of R and the time of T have to be the same. So let's explore. Oh, of course, your final amount A is what you started with, P, and how much you actually earned in interest I. I think that makes sense. Let's try this as an example. So if you did not follow anything that I said up till now, consider this. $100 is borrowed at a simple interest rate of 5% per A, which means per annum or per year. What's the interest that you have to pay back for 1 year, 2 year, and 10 years? I'm going to calculate all three. So let's write it out. My interest rate, I do not know. I'm trying to figure that out. What's my P? What am I starting with? Go, go, go. Go ahead, Zach. Yes. Sage, I'm coming to you next. Okay. At a simple interest rate, what is my R? Yeah. Okay. The simple interest rate, so that keyword is interest rate. If you're not sure, it's always going to be what your R is. And that is 5% as a decimal. You can't use percents in a calculation, so it has to be divided by 100. Okay. So once again, after your chapter 7, you should know already, but 5% is the same as 5 per 100. And you then the calculator, you get 0.0. Time, I'm going to do 3 different calculations. It's going to be 1, 2, and 10. I'm going to do all 3. So let's do it. If I were to borrow for 1 year and not pay back for 1 year, what's my P? 100. What's my R? 0.05. What's my T? 1. Quick math, calculator. Dun, dun, dun. Yep. Everyone's going to essentially be an accountant this month. So every time you come to class, please take out your calculator. 100 times 0.05. Mental math? No? Yep. Yeah. The interest is 5. So what's my total amount? $100 is what I start with. $5 is what I earn. My final value is 105. Oh, this breeze is kicking my butt. Finally, some relief. It's supposed to thunderstorm though, so please be careful. Let's move. If I were to deal with 2 years, does the formula change? Absolutely not. PRT, 100 times 0.05 times 2 years. How much did I earn? Which makes sense. I earned 5 years the first year. I earned another 5 years the next year. So together, if it's 2 years, how much money do I have? 110. Prediction. If I earned $5 in the first year, how much money did I earn after 10 years? 5, 5, 5, 5, 5, 5, 5, 5, 5. How much money did I earn in 10 years? 5 plus 5 plus 5 plus 5. 5, 10 times. Yeah, right? And that should be my answer. I equals 100 times 0.05 for 10 years. Put that in the calculator, you get $50. 5 times 10, right? So my final amount is 100 plus 50, that's $150. Super straightforward. But what did I say before in my little note? I said it is rarely used today. It's too simple. In fact, it doesn't do justice to how complicated finances can be. So let's take a look at how exponents will help us out. So let's take a look right here. Unfortunately, next page, almost no financial institutions use a simple interest for business. Does a Visa card only charge you interest for $1? No, they will charge you interest on whatever you have on your balance. They use some variation of compound interest. So let me try to explain. Do you recognize this formula from my previous little spiel? It looks very similar to VF is equal to VI 1 plus R to the power of T, does it not? Okay. And it's the same idea. A is your final value of money. P is what we call principal, and that is a financial term for the initial value of money. R is annual interest and T is time. Take a look at what happens. Everyone, please remember the $105, $110, and $150, okay? Hayden, you are welcome to put earphones on so that you don't have to listen to the air. Here we go. Example, $100 was borrowed. So 5%, look at the wording difference, was borrowed at a rate of 5% per A, compounded annually, not simple interest. The word simple is nowhere to be seen, and all of a sudden you see the word compound, so you know what formula to use. Right? So this is still 0.05. Everyone ready? Year one. A is equal to P 1 plus R to the power of T. P is 100. This is 1 plus 0.05 all to the power of 1. Actually, it's starting to get cold. Is it just me? Are people cold now? Or no? But this is nice. Must be nice to be young. All right. I think we can at least turn up that. So what's the final amount? Yeah. 105. Is it any different from before? No. Compare with the first page if you have to. It's still the same amount. So what is the actual interest that I earn? I'm going to do a little bit of algebra. Take the final amount and subtract it from my starting amount. So that's 105 minus 100. How much did I earn? $5. Same as before. At this point, you can say, oh, Mr. Kim, what's going on? What's the big deal? Every year afterwards is a big deal. So if you know where I'm going, please go ahead before me. Do the same thing, but for 2 years. And oh, what am I doing? Why am I writing 2? Hey, you got me? I just saw you holding a calculator. So. Yeah. Oh, sorry. No. It just calculating that. It should be something a little bit different. Try it out. 1.05 to the power of 2. N times 100. Oh, so stop right there. Who gave me that free 25 cents? Compare it with the first page, right? In simple interest, the final amount was $110. Why is there a difference? Hold that thought. I'm going to finish this question. So yes, there is a question, remember? And remember, for simple interest, this was 150, right? So my I, A minus B, that's 110.25 minus 100. The interest that I earn is $10.25. So it's not $10. Okay. Where did that 25 cents come from? Let's continue. Someone want to do 10 years for me, please? Cameron, go ahead.
I was going to ask the first question.
No, ask the question while other people are working on this. All right, then let's do this first, and then I'll come back to you.
Okay.
100 and something. Man?
Oh, I'm sorry. 105. I thought that was 105.
Go ahead. Man. 889. So because this is money, 889, I'm gonna round to 89 cents. Whoa. So if it's A minus P, it's 162 and 89 cents minus what I started with. Whoa, 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 whoa. Wasn't the interest for this 10-year cycle $50 last time? Where am I getting? So it's not a fluke. Where am I getting this free money from? Anyone? Cameron, you have that idea to enlighten the class?
Yeah, because it's an exponent instead of just added percentage.
Sure. So in terms of money, how does that make sense? Can you describe it in your own words? How does real life work in this case? Yeah? Interest that you made in the previous year is making interest for you. Your money is making money for you. You're not doing anything anymore. The idea is this. You know that you will make $5 on $100, right? So take a look. If you are investing $100, you gain $5, you get 105. In the next cycle, how much money do you have? You have 100 plus an additional 5. So for the $100, you gain 5%. What is 5% of $100? You gain another $5. But you also have the $5 in there already. So what's 5% of $5? 25 cents. That's why you're earning an extra 25 cents. And you know what? If for year number 3, you have the $5 from before, you have the $5 from the recent, and you have the extra 25 cents from the recent. So now, not only are you making interest on the $100, you're making interest on the $5, and you're making the interest on the $5 and the 25 cents. Your money is making money for you. That's the power of compounding. And it might not make sense to you just yet, but you have to at least appreciate that more interest is accumulating. And this is what we call snowball. If you let this go, you will make a lot of money. If you're in debt and you let this go, you will be in, well, a vortex. You will be in a bottomless pit and you can't get out because it's snowballing out of your control. And that's it. You need to appreciate the difference between compound, simple versus compound. So let me do one more diagram for you, okay? Maybe this might help people understand better if you're still not quite grasping what compound interest is. in the first month, let's pretend you invested, let's say $100. Okay, I'm gonna do this. This is times 0. With me so far? I'm just drawing it. You don't have to. Just see if you can absorb this and understand it conceptually. After 1 year, this is going to be a little sloppy, okay? After 1 year, you have this much, right? And you have a little interest on top of it. With me so far? Next, how much money? So look at this, multiplied by 1.05, right? You have a little bit more on top of it. Next, how much money do you have now? Gray and the blue together. So this, in the next year, is considered your total amount of money. And you earn a little bit of interest, 5% on top of it. And the next year, what can you say? Well, I have this much in my bank account. So this is going to be how much I start with. And then you earn 5% on that. So that is times 1.05. And so for the fourth year, again, how much is in your bank account? Well, I have this much in my bank account. So when again, just think about it. When I'm multiplying this by 1.05, 5% of this gray block versus 5% of this gray block, I think you can guess which one is going to be larger. Right? Do you notice that the blue is steadily increasing? The amount of interest you are gaining is increasing. And so by the time we get to 10 years, the amount of money that we actually have will be a total of all the blue stacks that we had. And how much is 5% of that huge block? Well, it's going to be much larger than the blue blocks of the previous years. So the amount that you gain every year is huge. It's a percentage of what you had before. Hence the reason why the rich get richer and the poor stay poor. What is 5% of $1? Let's keep it easy. What was 5% of $100 again? Well, yes, so 0.05 of $100. How much did I earn if you made 5%? We just did it. Come on, people. How much was this first interest? $5, right? So someone who's making, hourly wage, even if they invest, they only make $5. Would you rather invest a full year and earn $5, or would you want to just go out and work another hour? You want to work another hour. It's faster money, right? Make sense? So let's ask this. What is 5% of, let's say you run a business and you earn $1 million one day. What's 5% of that? Someone do the math. Calculate that for me. Not 5, but sorry, 50,000. You both waited the same amount of time. Who earned more money? The one with the $1 million. Why? They didn't work harder. They just had more money to begin with. That's it. The way the financial institutions work, the way investment works, the way money and accounting work, it's all percentage. So what matters is, how much are you starting with? So hence the rich get richer and the poor stay poor, right? But that's not to say the poor can stay poor forever. There are ways around it if you understand the math behind it. We can make this work for our own advantage. And that's our goal for this chapter. Okay. Again, I remember when I was in high school, math, as good as I was at it, I don't really care much about it until I started talking about money. And then my ears were like, you know, I was so attentive. I hope you get somewhat excited about it. I don't think I was particularly wealthy. I wasn't necessarily poor, but I definitely had much, much richer friends around me. And so stuff like this was very interesting to me. So let's read this final little bit before I essentially do one example with you and set you free. If you were the bank lending money to a client, which interest rate would you charge them? I think you would choose the compound interest because not only does it make sense logically, you can earn more money from it, right? No, time must match the time frame of the rate. So if the rate is per year, the time, the exponent must be in years. If the rate is expressed in months, time must be in months. So here's an interesting question. I purposely made some space so we can calculate together. Let's do number 10 as a class. Natasha borrows $3,600 to pay for university tuition. Awesome. That's not much compared to tuition nowadays. The annual interest rate is 8%. That is a scam. She will start to repay the loan in 4 years. So it's going to accumulate interest for 4 years. How much interest will be added if the interest is simple? Okay, pop quiz. What formula am I? And that is the use of I equals PRT. So when you plug that into the calculator, the interest is 1152. Okay. That's yeah, it's a lot of money. I'm not gonna lie. Just for 4 years, borrowing that much, that's like a quarter. That's a third. Crazy amounts of money. All right. For B, how much interest will be added to the original if the interest is compound? So compound, highlighting that word. If you see that word anywhere, you know that the formula is going to be our exponent, exponential growth formula. The final amount is 3,600, 1 plus 0.08, and that happens for 4 years. Work that out for me. I'll do it as well to confirm. I think I got it. We'll just finish off there. So just turn to the last page. Got it? Confirm with me 4,897 and 76 cents. Now that's not the interest. Please don't be fooled. Don't be fooled. That's not the interest. I have to calculate the interest because that's actually my final amount. That's how much my 3,600 grew to. So I need to do a subtraction to see what the difference is. This is 1,297.76. As a bank, if you are the person that is lending the money, which method makes sense? If you were the business, I think the compound interest makes the most sense. Please note the difference. For simple interest, the formula gets you the interest right away. So if you wanted to calculate the final amount, you have to do an extra bit. For compound interest, you get the final amount right away. So if you wanted the interest, you have to do an extra calculation. Okay. Any questions about the differences between simple and compound? All right. So then that's pretty much it. What I'm going to ask you to do for tomorrow in preparation, all that you need to do is make sure you are comfortable with the equations, simple and compound. Starting from tomorrow, we are not looking at simple because it's not applicable to us. I need you to know it exists, but we are going to focus on this. And I'm sorry to say, everyone, we are going to have a slight spin-off of this equation. It's not as linear. It's not as simple as just this one formula. There's a little addition because the world doesn't function on a yearly basis. If anything, in what time frame do finances and business run at, in your opinion? If you are a bank, do you run things on a yearly basis? Or is it a quarterly basis? Is it a monthly basis? How quickly do you think calculation and compounding is done by a bank? Let me give you a different question. Your parents, you might have heard something called a line of credit. People older than 18, you might have heard something called Visa. These kinds of things run on different time frames. So here's an easy question. What is a time frame before your Visa gets calculated? Anyone know? No? That's not good. Monthly. You have to pay back within the month. Okay? For things like line of credit and adulting things, they actually can calculate it on a daily. They calculate your interest on the daily. So we'll figure it out. I am going to stop the video here. Your expectation is that you try numbers 2, 3, and a bunch of the other questions below.